So we left off with 8 planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Of that, it turns out that we can actually learn a lot about. So we can learn a lot about the planets here. The innermost planets turn out to be what we call the terrestrial planets. They're all rocky planets. So Mercury, Venus, Earth, Mars. And here they are drawn to scale. The outer planets drawn to scale are Jupiter, Saturn, Uranus, and Neptune. The Jovian planets are sometimes called gas giants. The inner planets are mostly made of rock with iron or cores or something. The outer planets may have a solid core, but the outer parts of those planets is mostly made of hydrogen and helium. Hence, we call them gas giants. Now, really, that's the term that's normally used to describe them. It's inaccurate because if you squeeze a gas enough, you can squeeze it into a liquid. And it turns out that those planets are, in fact, mostly liquid. They really should be called liquid giants. Most of Jupiter and Saturn are actually made of hydrogen and helium. About half or near half of Uranus and Neptune are interestingly enough made up of water, and then the other half is made of hydrogen and helium. So we'll talk more about this later in the semester. Here they are all drawn to the same scale. And you can see, for example, now that the inner planets are tiny compared to these giant ones out here. In fact, you could fit 1,000 Earths inside of Jupiter and almost that many inside of Saturn. You could fit like 100 Earths or so inside of Uranus or Neptune. So that's why we call those giant planets out there. Orbits of these planets is interesting too, because the inner planets are all crammed close together, whereas the outer planets are all spread out. Okay, and so all these orbits are fairly close to circular. Mercury's orbit's kind of like a little bit out, but it is close enough to circular here. So these orbits all look pretty straightforward. They all go around the sun in the same direction. If you look at the solar system on the edge, then what you see is that everything kind of lines up, like a big fat DVD or something. Okay, so that's the solar system. Well, interestingly enough, early part of the 20th century, a fellow named Clyde Tombaugh was looking at 2 photographs here and noticed that one of the dots moved. Okay, that moving dot, he was able to calculate, was out beyond Neptune. Okay. By the way, pretty much every astronomy class has to at least have a picture of a star pattern with an arrow pointing to something. So there it is. Okay, so this thing, at the time, the only thing they knew in the solar system were small rocky planets or big gas giant planets. This thing, in the biggest telescope that was on Earth, was no more than just a dot. So they knew it couldn't be big like a giant planet. So that meant they figured it must be made of rock. Okay, rock reflects only like about 10% of the light that hits it or less, usually. And so that means that by looking at how bright it is, they guessed that it must be somewhere between Mercury and Mars in size. In fact, I remember, when I was a kid, I had a little play solar system, that little booklet that came. You could cut out the planets and so forth. And this thing, they called it Pluto, way out there in the outer part of the solar system, they showed it as between Mercury and Mars in size. Well, that's totally wrong because it's not made of rock. Okay, it's actually made of ice. Ice is very reflective. So that means that Pluto is much smaller than they thought. Pluto's really close to the size of Alaska. Okay, and so it's like, oh, okay, so it is too small to be a planet, they thought. The other thing was it had this weird orbit that wasn't lined up with any of the orbits. It was tilted at a funny angle. okay, and it was a tiny little thing. And so the solar system was Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto, but they were arguing about Pluto. They generally decided to just leave it on the list because, well, they found it and they figured it's the only thing like it out there. It doesn't conform. It's not a rocky planet. It's not a gas giant. It's like something. We don't know what it is. It's an icy thing. You know, comets are icy, so it's kind of like a comet, but it's way too big to be a comet. So they just left it on the list. Okay. Then they started looking at all the other things. Between Mars and Jupiter, there were a huge number of these little rocky things that we call asteroids. Okay, well, it turns out that some of the asteroids were also a little bit icy, and so that threw a huge monkey wrench into defining, what's what. They also realized that way out where Pluto was, there were a bunch of little icy asteroids that if they came near the sun, all that ice would heat up and blow off into space and make a tail. That's a comet. So Pluto was actually where the comet originated, and Pluto was made of stuff like a comet. So this was a huge argument out there. Comet orbits, by the way, unlike I drew there, most comets actually had very elliptical orbits, kind of like Pluto. They spend a lot of time way out here. They dive in close to the sun and then go back way out there. So again, this was, there were a lot of astronomers that were arguing that Pluto really didn't fit with the planet. It fit more with comets. Gerald Kuiper was the one who figured out all these objects were out here, so we call that the Kuiper belt. Okay. Well, then they just started discovering big things in the Kuiper belt, like Sedna and Quaoar, which were almost the size of Pluto. And then finally, they found something that we named Eris, which was slightly bigger than Pluto, but made of the same stuff, and had a very similar, really elliptical orbit out there. In fact, there's a whole bunch of things. Makemake, Sedna, Orcus, all these things are similar in size to Pluto. And so now the thing is, well, if Pluto is a planet, things bigger than Pluto ought to be a planet. Things almost the size of Pluto, but with similar orbits and composition ought to be planets. So I remember they had this big argument about what makes a planet or not. And so the International Astronomical Union came up with a committee of people, and they're the ones that actually determine the status of what objects are. And they decided that Pluto should not be in the list of planets. And so when they did that, they actually coined the term Plutoed to mean something kicked off the list. Well, Pluto wasn't the only one Plutoed. Ceres, Vesta, Pallas, and Juno long ago got kicked off the list of planets. Okay. The IAU Commission came up with a new designation for dwarf planet. A dwarf planet is something that is similar to a planet, orbits the sun, and it has enough gravity to pull itself into a round shape. A lot of the asteroids and comets are not round because they don't have enough gravity to pull themselves into a round shape. We call that hydrostatic equilibrium. So if they orbit the sun and they pull themselves into a round shape, they thought first that's going to be enough to make them a planet. Well, the problem was we knew that these were all going to be planets, but there were almost 80 other objects out there that may or may not be planets. Okay. I remember when they took Pluto off the list, I gave a presentation in elementary school. And the kids were going, oh, we love Pluto. We want Pluto to be on the list. And I said, okay, here, kids, you have an option. You can memorize 8 planets in orbit, or you can memorize 80 planets in orbit. And so the kids in elementary school there at that point were unanimous that Pluto was no longer a planet. Okay. And so we have 8 to keep track of. If it pulls itself into a round shape, that's not enough. It has to have enough gravity to basically disrupt the orbit of everything nearby that's similar in size. So we call that clearing the orbit. Only these 8 are big enough to do that. Pluto, Ceres, Eris, Makemake, Haumea, they all cross orbits with other objects similar size, and they don't have enough gravity to mess up the other orbits. So we call those dwarf planets. Okay. So that's big enough to pull itself into a round shape, but not enough to clear the orbit. So we've now gone from, when I was a kid, 9 planets to 8 planets and 5 confirmed dwarf planets and dozens more suspected dwarf planets to over 4,000 confirmed planets we discovered around other stars, and about 3,000 more planets that have been reported around other stars but not yet confirmed. You make a discovery, it doesn't count unless another astronomer comes along and verifies it. And so there's about 3 more reported discoveries out there. So all of a sudden, this is way different from what it was when I first started doing astronomy, in which the only planets we knew were 9 of them in the solar system, and we argued about one of those, okay, whether it should be on the list or not. I remember very early on when I first started teaching astronomy, I said, Pluto probably should not be on the list. Eventually it got taken off. Okay, but this is our overview of planets. I want to point out, planets are not everything in the solar system. We have moons, and some of these moons are huge. In fact, 2 of the moons, Ganymede, which orbits around Jupiter, and Titan, which orbits around Saturn, are both bigger than the planet Mercury. Callisto's almost the size of Mercury. Even our own moon is pretty sizable compared with the planet Mercury. And so a lot of these large moons are in fact worlds. Ganymede seems to have evidence of plate tectonics on it. Titan has an atmosphere. It's got rain, it's got oceans. Now, granted, it's not water rain or water oceans, but it is liquid methane rain and liquid methane oceans. Io has volcanoes, very active, it's the most active volcanically thing in the solar system, and there's evidence that Europa has a salty ocean under a layer of ice. So this would be very much, climate actually very similar to under an ice shelf on Earth. So it's actually one of these places that we look at as a potential habitable world. Okay. And so planets are not the entire thing in the solar system. So our solar system, obviously, we got the sun, we got the planets, we got the dwarf planets, we got what we call minor planets, that's the asteroids. We have these icy things, which are the comets or Kuiper belt things if they don't come close to the sun. We have the moons, that's the natural satellites, little small things running around the solar system, that's meteorites, and even smaller, that's interplanetary dust. So these are all parts of the solar system. When I first started, we didn't know nearly as much as we do today. There are millions of asteroids out there. When I first started, we knew of a few thousand. Okay. Understanding what Earth is, the planet Earth, because that's very important. It's the only planet we can live on. How does it work? What affects the Earth? Understanding all that means understanding how planets operate and how they function in the solar system. How did Earth get to be the way it is? It's the only one that's habitable. Why are the others not habitable? Okay, and wait a minute, is there something useful we can use out there? It turns out that a lot of these asteroids have platinum, gold, silver, iridium, rare earth elements, things that are exceedingly valuable on Earth just laying around on the surface. And so that means that there's financial reasons to study the solar system. And of course, the other thing is, if humans manage to wreck Earth, is there any place else we can live out there? And so that's basically why we need to study astronomy. As I said, there's been over 4,300 planets discovered around other stars. Okay, and so understanding Earth helps us understand, and understanding them helps us understand Earth.